Okay, guys, welcome back to our last lesson from Activity 7. So in 7-3, we're going to be talking about perpendicular lines. So today we're going to determine if lines are perpendicular. We're also doing some solving using theorems about perpendicular lines. So make sure you have your Springboard book open to page 84, something to write with, your vocab sheet, and maybe a calculator if you need it. So let's go ahead and get started. So our first vocab word here is perpendicular. So we kind of already talked about perpendicular lines a little bit, but perpendicular lines intersect to form right angles. Okay, so if two lines intersect, I'm just going to kind of draw some lines here. Okay, they're said to be perpendicular if they form right angles when they intersect. Now, technically, we're going to get 4 right angles from perpendicular lines because each angle that it causes is going to cause a 90-degree angle. That's what makes something perpendicular. Okay, so let's kind of jump down here to these other little math terms. So we have a perpendicular postulate, which says that given a line and a point not on the line, then there's exactly one line through that point that is perpendicular to the given line. So that's a little wordy here. But let's look really quick at this picture here. So they have this line WX. So they're saying that we can make a perpendicular line, okay, through that value. Okay. So let's say through this point W. So there's a point W that is not on the line X or XY. But we can form a perpendicular line through that value. So that's what that postulate is saying. Okay, given a line and a point, there is exactly one line that goes through it that forms perpendicular lines. Okay, so similarly, there's a parallel postulate that says given a line and a point not on the line, there is exactly one line through that point that is parallel. Okay, so same thing. That just is saying, it's really wordy way of just saying that we can also have, if we have a line, we can have another line parallel to it. So I can have like another line parallel here. Okay, so given a line XY, we can make a line that's perpendicular, and given any line, there's always at least one line that is parallel to it. So that's those postulates. Okay. Let's go to the next slide here where they talk about the perpendicular transversal theorem. Okay, so that states if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So let's just kind of draw in some lines here really quick. So I'm not really going through these questions, but I'm going to use this space to kind of draw in my lines. So say we have two parallel lines here. Okay, we know they're parallel, so we'll mark them as parallel. I'm going to call them M and N. Okay, so say we have a transversal that cuts through that line. So let's make that transversal. I'm going to make it orange. Oops, let's try that again. Okay, so they're saying if your transversal is perpendicular to one of the parallel lines, so say that transversal, let's call it L. Okay, if that transversal is perpendicular to line M, okay, then it has to be perpendicular to line N. It has to be perpendicular here also. Because remember, if these lines are parallel, that implies that these angles that are corresponding angles are congruent, right? So let's say I call this angle 1 and angle 2. Angle 1 has to be congruent to angle 2. So if angle 1, they told you, is a right angle and it's perpendicular, then that means angle 2 also has to be a right angle. It also has to be 90 degrees. So that makes that one also perpendicular. Okay, so things we can say here, if M is perpendicular to L, then N has to be perpendicular to L. It's kind of like using the transitive property a little bit here too. Okay, so that's what that perpendicular transversal theorem says. If it's perpendicular to one of the parallel lines, it must be perpendicular to the other parallel line. Right, let's jump down here to the next one, which is a perpendicular bisector. Okay, a perpendicular bisector of a segment is a line or part of a line that intersects the segment at its midpoint to form right angles. So again, little wordy of a definition, so let's just kind of break this down. So they're saying that Matt draws AB, so he's going to draw a segment AB. So let's draw that really quick. So labeling this AB. Okay. He's going to say that line XY is a perpendicular bisector. So let's draw an XY now. So there's our point XY, or our line XY. So in order for something to be a perpendicular bisector, so remember, bisector means it's going to cut that segment, okay, or whatever that is, into congruent parts. So they're saying that this line XY is going to intersect AB at point M. So here's where that intersect is. So for something to be a perpendicular bisector, it's going to intersect the segment at its midpoint, meaning it's going to bisect the segment AB, giving me two congruent segments. So the conclusions that I can get from this is that AM is congruent to MB. If that crosses at the midpoint, that makes this divided into two congruent parts. Okay. Also, if it's a perpendicular bisector, we can assume that line XY is perpendicular to segment AB. So that's another conclusion we could make. Okay. Lastly, we can also kind of make the conclusion, and they told us this in the definition, that M is the midpoint of segment AB. Okay. So a perpendicular bisector is going to bisect, meaning cutting it into two congruent parts. But what makes it special is it bisects it at a 90-degree angle. Okay. So a perpendicular bisector makes perpendicular lines 90 degrees all around here. And it bisects that segment at the midpoint, making sure that you have two congruent parts. So there's all the conclusions that we can make about a perpendicular bisector. Okay. So let's just flip to the last page here and do some problems that apply this. So jump to that, check your understanding. Let's look at lines A, B, and C. So they say lines A, B, and C lie in the same plane. A is perpendicular to B, and B is perpendicular to C. So let's draw that first before we actually start doing too much. So let's see. Looks like we have some lines here. And we have a line that is perpendicular. Okay, so here's what they told us. They told us that we have line A is perpendicular to B, and line C is perpendicular to B. So if it's perpendicular, again, we know that these are right angles here. Okay. So they want us to ask, can we conclude that A is perpendicular to C then? So from this picture I kind of drew, if A is perpendicular to B and B is perpendicular to C, can we say that A is perpendicular to C? Well, hopefully you kind of figured out that no, okay? If you look at this picture, A and C are not even touching each other, okay? So A and C are actually parallel. Okay, A is parallel to C. Because if we look at these angles, okay, we have this angle here, we know is 90 degrees, right? This angle here is a corresponding angle, which is also 90 degrees based on the fact that we know that they're perpendicular. So here we have corresponding angles, which we know corresponding angles are congruence, helps us prove parallel lines. Okay, so we could say they're parallel because we have corresponding angles. And those angles are congruent. Okay, so definitely cannot conclude that A is perpendicular to C. All right, number 8 says RS is perpendicular bisector of JL. So I'm just going to mark this up a little bit. So RS is a perpendicular, so you can see that little square there. And if it's a bisector, that means these two segments have to be congruent, JK and KL. Can you conclude that point K is the midpoint of RS? So they're asking us to look at RS. So based on that given information, can we say that K is the midpoint of RS? Yes or no? What do you think? Okay, well, here the answer again is no. Okay, we don't know anything about RS. It could be that it's the midpoint, but we have nothing to say here that it is. In this point, since we know that it was a perpendicular bisector, we know that the segment that it cuts through, that's the midpoint. Okay, so K is actually the midpoint of JL. That's the only segment we know it's a midpoint for because of what a perpendicular bisector does. Okay, we do not know that it's the midpoint for RS. All right, last two questions. Let's look at 12 and 13 here. So in this picture, we're going to look at the figure here. No, actually we're not. We're going to make our own pictures. So let's see. 12 says the perpendicular bisector of CD intersects CD at point P. So let's draw this really quick. So we have a perpendicular bisector of the line CD. So let's label this C and D. And it says it crosses at point P. Okay. So they want to say if CP is 12, they want us to find the length of CD. Okay. So again, think about what a perpendicular bisector does to the segment CD. See if you can figure out what is the length of CD then. Okay, so the length of CD should be 24 because this is a bisector. That means these two segments, the midpoint then is P. So CP has to be congruent to PD. So if CP is 12, PD is 12. And by the segment addition postulate, I can add those together and give me an answer of 24. Okay. All right, last question. An angle formed by the intersection of two lines is obtuse. Could these lines be perpendicular? So let's draw in some lines here. So we're saying the intersection of two lines. They're saying that this angle is, if they're intersecting at an angle that's obtuse. So let's say this is our obtuse angle. Okay, so remember, obtuse is any number that is larger than 90 degrees. So if it's obtuse, let's call it, I don't know, 100 degrees. That's larger than 90 and it's easy to work with. So say these two lines intersect at this angle of 90 degrees. Well, vertical angles would say that this angle across from it would also have to be 100 degrees. Okay, and since these lines would be supplementary to form that straight angle, then this would have to be 80 degrees, and this line would have to be 80 degrees. So if it intersects at an obtuse angle, can we get perpendicular lines on any of those? Well, no. Okay. There's no way that we're going to get a 90-degree angle here if one of those angles is obtuse. Even if this was like 91 degrees, still couldn't do it, right? Because we'd have 91, 91, 89, and 89. Okay, so still no 90 degrees there. So final answer here is no. We cannot say that any of those lines are perpendicular. There's no way we would get a 90-degree angle. Okay, so that is everything perpendicular. So the main takeaway today is about that perpendicular bisector and being able to use it. Okay, remember, bisector cuts the segment into two congruent parts by passing through the midpoint. That's what makes it a perpendicular bisector. Okay, and also making that right angle there. Then the other theorem kind of that's important that says if we have a line that is perpendicular to one parallel line, it must be perpendicular to the other parallel line and vice versa. Okay, so that is the end of activity 7. So we will be preparing for that comprehension check soon.